Hello everyone. Let us start with Unit 2, which is Measures of Central Tendency. Let us see the definition. It is a number which represents or describes an entire group of data with a single number or a single data is called as measure of central tendency. For an example, here we have taken an example of test scores of a few students who have scored marks as 82, 76, 75, 90, 71, 72, 80 and 83. Here we have a set of scores. These set of scores we can express it as average percentage of. If we take average of these 8 students, average percentage of these 8 students will be equal to 79%. If I add all these values and if I divide this by 8, I'll get it as 79%. This is a single number which represents an entire group of data. This is nothing but a central tendency. Let us take up one more example. Suppose if we take an average weight of 50 students in a class, their weights will differ. However, there will be only one value which will be the representative of all the weights of the students in that class. That value will be called as the central value. This is nothing but a central tendency. So we have few measures of central tendencies which are discussed like this. Measures of central tendencies are, we have mean, median and mode. We have three measures of central tendency. They are mean, median and mode. So in mean we have three types of means. One is arithmetic mean, the second one is geometric mean and the third one is harmonic mean. So first let us deal with arithmetic mean. It is nothing but a set of values obtained by dividing the sum of the values by number of values in the set, and it is denoted by x bar. For example, if we have set of values x1, x2, x3, etc., xn, or the set of observations, then arithmetic mean is defined as x bar is equals to sum of the values divided by number of values. Sum of the values means addition of all these set of values, x1 plus x2 plus etc. up to xn, divided by number of values is n. So x bar, using summation, we can write this as summation I equals to 1 to n xi divided by n, or in general it can be written as summation x divided by n. This formula holds good for ungrouped data. Ungrouped data is nothing but the data which is not sorted into categories or not sorted into different groups. Suppose if the observations are like this, x1, x2, xn, having the frequencies say f1, f2, etc., fn, then arithmetic mean is defined by x bar is equals to f1 into x1 plus f2 into x2 plus etc. fn into xn whole divided by f1 plus f2 plus etc. fn, which is equals to, if I put this in the summation, summation I is equals to 1 to n fi into xi divided by fi, or in general we can also write it as x bar is equals to summation fx divided by summation f, or summation fx divided by the summation f can be written as capital N. Capital N is nothing but the total frequency. This formula holds good for the grouped data. That is, a grouped data is nothing but the organized data or the data which is sorted into various groups. So this formula holds good for grouped data. So again we'll recall the formulas. For raw data or for ungrouped data, arithmetic mean x bar is given by summation x divided by n. For tabulated data or for grouped data with frequencies, arithmetic mean x bar is given by summation fx divided by n. F represents frequency and this capital N represents the total frequency. Let us see an example. Here, heights of 6 students are given as 163, 173, 168, 156, 162 and 165 centimeters. Find the arithmetic mean. They are the ungrouped datas. So we know how to calculate arithmetic mean. Arithmetic mean is given by x bar, which is equals to summation x divided by n. Summation x means addition of all these values, 163 plus 173 plus 168 plus 156 plus 162 plus 165, whole divided by the number of values is 6. So x bar is equals to 987 divided by 6, which is equals to 164.5 centimeters. Let us take up the second example. The following is the frequency distribution of the wage workers of a factory. Find the arithmetic mean. So daily wages in rupees is given 80 to 100 rupees. The number of workers is 8. So the number of workers getting between 80 to 100 rupees is 8. Between 100 rupees to 120 rupees is 22. Between 120 to 140 is 26. Between 140 to 160 is 14. Between 160 rupees to 180 rupees is 10. So this is nothing but a grouped data with frequency distribution. So to calculate the arithmetic mean, we have a formula x bar is equals to summation fx divided by summation f, or this can also be written as capital N. So let us calculate this value summation fx and summation f in the table. Let us reconstruct the table by using the given data. So let us write down the class interval. Between rupees 80 to 100, the number of workers is 8. Let us call it as F. Between 100 to 120, 22. Between 120 to 140, 26. 140 to 160 is 14. 160 to 180 is 10. So total frequency that will be summed up and will be called as summation F is equals to 80. Let us calculate the mid values of 80 to 100. To calculate the mid values, which will be called as x, between 80 to 100, to calculate the mid value, add these two values, 80 plus 100 divided by 2. The mid value is 90. Similarly, 100 plus 120 divided by 2 is 110. 120 plus 140 divided by 2 is 130. 140 plus 160 divided by 2 is 150. 160 plus 180 divided by 2 is 170. I got the value of x. I got the value of frequency. I'll take up the product of f into x. So f into x gives me 720. 22 into 110, 2420. 26 into 130 gives me 3380. 14 into 150 gives me 2100. 10 into 170 is 1700. So summation fx means addition of this column gives me 10,320. So I can substitute all these values in the formula. Summation fx value is 10,320 divided by summation f value is 80, which is equals to 129. So my arithmetic mean x bar is equals to rupees 129.